Often you'll have to locate information from multiple sources and then combine it into a single data frame in order to visualize it or do other kinds of reasoning with it. And so an example of that is the data that we've been graphing so far from the names database. You'll notice that on the y-axis we have name count. And this is sort of standing in for popularity in that names with higher name counts are probably more popular than other names, all other things being equal. But all other things aren't actually equal because this data actually spans from 1915 through 2014. And the number of babies that were registered with the Census Bureau was much smaller in the 1900s than it is now. So if you really want to know popularity of a name, you don't actually have everything you need in the data frame that we've been using so far. Because what you really need to do is look at the ratio of the name count for a particular name to the total number of babies of that particular gender that were registered in a given year. And that's going to adjust for fewer babies being registered in the 1900s than later on. So how do I get that information? Well, it actually is in the names database already, but for the sake of this demonstration, I'm going to pretend that it's not part of the table that I was writing the query on so far. So let's actually look at the query that's being executed. Here it's fetching Jesse from all data. And I'm just going to pretend that that's all I really have available from this query. But I'm going to write a separate query to fetch information about the total number of babies that were registered each year. So I'm going to copy that query and scroll down to where I was before. And let's go ahead and add a new cell. And then for this query, instead of fetching a data frame, I'm going to fetch, call it babies registered. And I'm going to select everything to start with out of a table called year gender totals. And then I'm going to take a look at the contents of what I get coming back. So this is coming out of the same database where I'm getting the names data, but it could be in a separate CSV file or stored somewhere on a website that's separate from my database server. And then what I'm actually getting back is year and gender for 1915 through 2014. And then the total number of babies of that gender that were registered in that year. So that's what I need. Then this year gender total ID, I don't actually need that for anything. And then this index is just an index. So how can I take this and add it to my Jesse data so that I can calculate the ratio of name count to this total? Well, if you're writing a SQL query, you just use a join for that. And the keys that you're joining on are going to be year and gender. And in fact, Pandas has a join as well, but it's a little bit different from what you're used to when you're working with SQL. So in Pandas, a join is going to be by default based on the index for the table. So right now, let's look at the data frame. So my data frame is has no index or just this numeric index. And the babies registered just has this numeric index. And if I join these two things together right now, it would match row 0 here to row 0 here and row 1 here to row 1 here. And that's not what I want at all. So the first thing I want to do this join is I actually want to set the index for both of these data frames so that year and gender are the index. And then when I join those two things together, they're going to connect the rows where year and gender matches in both data sources. So let's go ahead and do that. So I'm going to do df.setIndex, and then I want two columns for my index. I want year and gender. And then I'm going to go ahead and do this in place. And then let's print df. And then I'm also going to do the same thing with babies registered. So that's going to have year, oops. That's going to have year and gender as the index as well, and in place is true. And then let's print babies registered as well. So my Jesse data, the data frame, I now have a 2-level index. So first level is year, and for all of the records where the year was 1915, I have 2 separate genders, and then there's name and name count for this combination of year and gender, and so on. But I got an error with babies registered. And that should have been babies registered.set index. So I've modified this in place already, so I'm probably going to get an error. Yeah, so I can't execute this line of code again because I already modified it in place. So let's go ahead and try that. So df still has the right values, right index, and then I have a matching index for babies registered. So let me go ahead and add another cell here, and here I'm actually going to do the join. So df.join, and this is going to be the left table, and then inside of the parens I'm going to put the right table, which is babies registered. And then if I do shift tab to see what the arguments are, you can see that all the rest of these are optional, but I can specify on for this table, and if I specify on for this table, it will say what column in this table should match the index in the left table. And then how can be left join, inner join, or right join. L suffix and R suffix are when you use the same column names in the left table and the right table. In the resulting join table, you'd have 2 copies with the same column name, and you don't want that. So that will in fact be an error to Pandas. So Pandas will ask you to supply a left suffix that gets glued into the left column name, and an R suffix that gets glued into the right column name, so that those 2 things are unique. So I don't need to specify anything here for the join. I'm not going to specify in place, and so if I do this dr join, I see that I have year and gender, and then name and name count from my df data frame, and then year, gender, total ID, and total from my babies registered data frame. So now that I have both of these things into the same data frame, I can do my calculation. So I can say like df sub percent is going to be equal to 100.0 times df sub name count divided by df sub total. And got an error there. Let's see what I got. Key error total. Let me try that again. Let me print df here. Oh, I didn't do that in place, so df is equal to that. There. So now let's look at df. And I got an error here because I changed the value of df and then overrode it. So let me go back up here. I'm actually going to go to the top here and execute that fetch. And then reread babies registered. And then execute both set indices. And then execute my join. So now that time I was able to calculate percent appropriately. And now if I go ahead and plot the data, so for index, I want year, and then I want to use a pivot to convert gender to a wide format, and I want to use percent as the value column. So let's try df.pivot, and then index is year, and actually I have to reset the index first so that year is a column. So reset index.pivot, index is year, columns are equal to gender, and values are equal to percent. And that will give me a table that looks like this. So I have two columns for female and male with percent, and then year is the index, so I can plot that. Okay, and we see in the peak, 0.35% of female babies were named Jessie, and 0.15% of male babies were named Jessie. For a really popular name like John, let's see what we get. So I'm going to go up to here. Let's do John. And set the index, pivot. So here we see it looks like John is less popular in early years than it is in later years. But in fact, if you bring in the babies registered and calculate percent, and then plot that, you'll see that John was actually most popular in 1915, 1916, and so on, where over 5% of the babies that were registered with the Census Bureau were named John. So there's an example of why you would want to factor in the total number of babies registered to get a more accurate estimate of popularity. So that's without the number of babies registered, and here it is with the number of babies registered.